Okay, there is actually a way of creating the magic squares using some algebra. Uh, you can find the formula for doing it quite easily, but I'm going to take you through the logic of how you might be able to explain why it works. So what I'm going to do is I'm going to just create a quick grid on the right hand side for us to record our results in. Okay. So as we make logic or deductions about what happens in here, we can put them in. Now, a little rule to realise is I'm going to be using letters A, B, C onwards, which suggests that these numbers must, or these algebraic terms must be linked. So let's have a look at a couple of the examples. The first thing we need to think about is trying to work out, if I know a row or I know a magic number, what can I say about the rest of this grid? So let's make a list of the magic numbers and the total, because the total one is useful for finding particular patterns of numbers if they will work. You work out the total and you can then work out what the magic number is, therefore we can work out some of these patterns. And we want to know the number in the centre. Is there a relationship? Now, because I've chosen it, we know there's a relationship. So, let's look at the first one. First one there, total is, magic number is 9, total is 3. So we know that the centre 3 is the magic number 9. If this line is 9, and this line is 9, and this line is 9, the total is going to be 27. Come to the next one, that's another 3, and that's another 9 going diagonally, 1, 3 and 5. Well, I've basically done that one, so I don't need that example again. We've got a 2 in the centre. We've got 4 and 2 and 0 is 6. And if I've got 6, 6 and 6, we've got 18 coming down. 1 in the centre, I've not seen that before. So 1, 0 and 2 is 3. 3, 3 and 3 in the row gives me a total of 9. That's not going to help me until I work out the middle one. That one's a repeated 1, that's not there, nothing there, nothing there, nothing there. And then we get some negative ones. I've got minus 2 in the middle. 2 plus minus 2 minus 6 gives me minus 6. And if I've got minus 6 in each row, I must have minus 18 total. Last one, minus 1. The line is 0, minus 1 and minus 2 is minus 3. So the total in the grid is minus 9. So is there a link? Well, yeah. 3 goes to 9 by either multiplying by 3 or adding 6. 2 goes to 6 by multiplying by 3 or adding 4. Well, the times 3 seems to be continuing constantly, so we may not be an add a number pattern. 1 to 3 is a times 3 pattern. Minus 2 to minus 6 is a times 3 pattern. And minus 1 to minus 3 is a times 3 pattern. So this centre number tells me my magic number. So if I now say the centre number is number A, the magic number is 3A. So I can now put A into my grid. Next part, total may not be necessary all the way through, but when you start looking at them, you actually find the total is 9 times A. Minus 1 times 9, minus 2 times 9, 1 times 9, 2 times 9, 3 times 9. So the total is 9A. It's 3A, total is 9A. So now we're going to look around and think, if I just had a whole number system, we know that each row, each column must have the same, must have pairs of numbers either side that balance to give us this 3a. So if I say this is the largest and this one is the smallest, I now know that these two are linked. So this one must have an a plus some number. Now I'm not going to call it b, c at the moment because we don't know what it is. So I'm going to call it m. And going the other way is a minus m. Going up and down, I've got another pair of numbers. I've got a minus n and a plus n. These must be different. Then when I start looking in the corner, you might say that they've got to have their own separate numbers, but you might realise that whatever's in this corner needs to be starting to try and cancel out the minus m minus n's, and in this cancel must cancel out the plus m plus n's. So these numbers must be linked as well. So this one's going to be a plus m, minus m minus n. And this one must be a plus m plus n. That gets rid of these two, but that then means these two must just be a. So another way would be to actually, how could I use two numbers to make the largest value? So I'm just going to clear out all the way back to the largest a's and a's and m's. And this is where the sticking point was. It's making this jump that on the sides we're making up from three numbers, not from one number or two numbers for each side. If I now try going across, a plus b plus c must be my largest number, and the smallest is a minus b minus c. What I can then start doing is go, well, this bit in the corner can get rid of one of these. So a minus b in that bottom corner, we get rid of the b. And a plus minus c would get rid of the c part. This row would then be 3a. This column, sorry, would be a, which is 3a. Minus c plus nothing is no c's. No b's plus b minus b is nothing. So this seems to be working to create my 3a. Let's go to the partner diagonally then. So diagonally, a minus c gives me one part. So a plus a, I need a third a. I need to cancel out the c somewhere. So a minus c becomes a plus c, and there's no b term needed. Well, if that pattern's worked, I can now work through and go, another diagonal, there's a minus b, that must be a plus b. We've now got this as a minus b minus c, and what we're left with on the top is we've got an a, we've got to cancel the minus the b, so we've got a minus b, and we've got to add a c. At the bottom, we've got to cancel out that c, so we've got an a minus c, but we need to cancel minus b by adding b. So we now have an algebraic grid that balances when I have three numbers in it. So the top largest number is a plus b plus c, a minus b minus c is the smallest. This is when a, b and c, this argument works for a, b and c are all greater than 0. It must be 0 or higher because of this largest and smallest relationship. As soon as you get negative numbers, that smallest bit doesn't work properly. It doesn't matter because the pattern still actually works. So I'm not fill in all of my remaining algebraic parts. Now you may see it rearranged in different ways, but there we are, we've got a magic square with all the magic numbers. That actually means that you can take on a challenge, and the challenge would be put the numbers from 1 to 9 into a magic square. And to do it, you need a value of A, B, and C. B and C are interchangeable in these, but so they're doable. Okay, so now that's the introduction to magic squares and the algebraic way of finding a form.